Today we will talk about memory. First, we would like to thank the Instituto de Investigaciones Filosóficas, Sociedad Argentina de Análisis Filosófico, and the Instituto Tecnológico Buenos Aires, ITBA. And a special thanks to Dante Kienigiel, who is streaming the seminar in YouTube. It is a pleasure for us to introduce Dr. Sarah Robbins from the University of Kansas. She works in philosophy of memory, and she's an expert on memory traces. It is also a pleasure for us to introduce Dr. María Eugenia Pedreira from the Instituto de Biología y Biología Molecular y Neuroscience, CONICET. And it is a special pleasure for me because she was my doctoral supervisor. She's a biologist, an expert on memory reconsolidation, and works in animal models as well as in humans. Marina?
So I'm going to introduce a little the format of this seminar. It's 30 minutes for each speaker. You cannot do ask questions while they are presenting, so you have to wait after their presentation. And the idea after their presentation is to try to create a space where both speakers can discuss between them a little, if they wish, of course, and then you can start asking questions. So that's it. It's Sarah Robbins who is going to start. Sarah, her talk is about the memory trace, of course, and the name of her talk is The Memory Trace in Philosophy and Neuroscience. So if you want to start to share your screen.
We'll do that. Oh, where did it go? I'm sorry. Normally this goes much better. Hold on. I don't know why it's doing this to me. Sorry. It's not showing me the option of my screen, which it normally would. Oh, there it is. Sorry. I feel like I should be an old pro at this by now, and I'm not. So, all right, thank you so much for the opportunity to do this today. Yeah, there are many hard things about this time, but the opportunity for these kinds of experiences is really nice, and I'm really grateful for the chance to do this. So the talk I had in mind today is it's a sort of big picture claim. I feel like, especially seeing a lot of philosophers in the audience, I feel like I should apologize ahead of time that I think I'm just going to make a lot of claims. I took most of the arguments out, and then you can't ask me questions until after Maria's talk, so maybe that will give me enough time for you to forget all those questions. But the idea was just to talk about the idea of the memory trace and sort of lay out what kind of idea about the core conception of the memory trace as I'm wanting to develop it. So the idea of a memory trace is an old idea. I would argue, if I were giving arguments, that the idea of the memory trace is as old as our theorizing about memory itself. So as long as people have been thinking about the idea of retaining information over time, they've been thinking about the idea that we do this via some kind of trace. And the term engram is a sort of more recent, a term that's been around for now maybe 130 years-ish, which has a similar meaning as a sort of scientific version, I was going to say scientized version of a memory trace, really referring to the kind of neural mechanism that supports the memory trace or the act of remembering. And although the memory trace and in its current form, the engram, have been with us for a really long time, I think our understanding of what a memory trace actually is incredibly limited. And the limitation comes in large part, I think, from a very, very heavy reliance on metaphors for how we make sense of what memory is. So the memory trace is often referred to as an impression in wax, or items in a warehouse, grooves in a record, RAM on a computer, right? As the historian of psychology, Dreisma, puts it, which I really like, you can think of the history of memory as a little like a tour of the depositories of a technology museum. And I think, memory is not unique in this way. I think we often use metaphorical allusions to our technologies to make sense of the mind in general and various of our cognitive capacities. But I do think that memory is distinctive in the way in which it so extremely relies on its metaphors when it comes to making sense of what memory traces are. So there haven't often been many accounts which try to go further beyond that metaphorical characterization and saying what the memory trace might actually consist in. And so a central aim of my work and some things that I've done previously and in some bigger things that I'm working on now is trying to sketch out what that commitment might be, what the sort of theoretical conception of a memory trace is. So again, I'm giving a kind of high-level picture of work today, putting together several different things. And what I want to do is argue that there is something of a substantive core conception of the memory trace that we can find in both philosophy and neuroscience. I'm going to spend most of my time just telling you what that core conception is rather than arguing for the ways that it can be found there, but of course you can push me on that. And then I want to say that the core conception can withstand many of the challenges that contemporary philosophers and neuroscientists have thought were devastating to the idea of the trace. So although the trace is a long-standing idea, it's not a very cool idea nowadays. I'm very aware of. I feel sort of like like some sort of curmudgeon for arguing for the ways in which we can keep this sort of idea around and that it has a role to play. So there are lots of objections to and ways people have of thinking that this is an outmoded or an outdated idea, one that's not in keeping with a lot of the contemporary evidence that we have. And while I do think that that evidence poses some challenges and some challenges that need to be thought through, I don't think that the core conception is actually challenged by those ideas. So I'm going to sketch through why I think that's not the case today. So I'm going to start with this quote from Endel Tulving, the sort of very prominent memory scientist, because I really like this, right? So he says, when he's talking about memory, he says, an event happens, a person experiences it, memory traces are laid down representing the event, the past vanishes and is replaced by the present. The memory traces of the event continue to exist in the present. They are retrieved and the person remembers the event. This, in a nutshell, has been the understanding of how memory works. It is simple and straightforward. There is no need or room for magic or for marvel, which, of course, nonetheless, there is plenty of magic here and marvel and challenges to be raised, but he's giving us a kind of characterization of what the basic phenomenon is and sort of centrality of the memory trace to thinking about how we want to characterize that act. And I think we can sort of build up to what the general conception of the memory trace is supposed to be from these kinds of sentiments. So if we try to take a big sort of, 5,000 feet in the air, I don't know what metric I want to use, right? Try to take a distant view, a sort of survey of the land of what we think memory is, trying to abstract away from particular theories and commitments, right? The idea of remembering something is at some, again, broad level of description that you have some kind of an experience, you undergo some change, and in some way, because of that change, you have the ability to remember or reactivate that experience, right? If I were to say to you, if I just interjected into the talk right now, as I'm about to do, and just said the word marshmallow, and then went on about the talk, but then somewhere near the end of the talk, maybe we're in some Zoom chat rooms or something, and you start talking to someone about how it was so strange that I put that word in the middle of my talk, right? Your ability to call that back to mind and to talk about it later is due to the previous experience, and something must have happened to you and or your brain in order to make that possible, right? That's the sort of basic central idea of what a memory is across its various forms and types. And that change that explains the connection between that prior experience and the ability that emerges as a part of it is that change in both the sort of metaphorical conceptions in philosophy and our understanding of the neural mechanisms. I just have a picture here of some neurons in the hippocampus and under microscopy, right? Just sort of shared idea in both of these cases. And of course, philosophers and neuroscientists, when they're thinking about this, are interested in and aiming in different places. A lot of philosophical work about memory traces has been giving arguments for why it is we think that a memory trace is required. What is the relationship between that initial experience and subsequent abilities that compels this idea that there must be something doing that intermediary work, right? Where neuroscientific work more broadly is to think about the characterization we have here as something of a functional characterization of an activity of an organism, where what we're looking for are the mechanisms that could make that possible, right? The neural processes that could support those experience-dependent changes in the brain and elsewhere, right? So both accounts are, I'm just going to say very briefly kind of what sorts of things they're doing. So when philosophers are asking why a memory trace is required, we give lots of different arguments for why that's the case. And of course, any of those individual arguments are going to have slightly different and sometimes more significantly different impacts on how one thinks about what the trace must be like in order for it to meet that requirement. So your ideas about what compels us to think the trace is necessary are going to influence what features you think the trace must have. I'm not going to survey all of these accounts. I put an asterisk up against the last one, saying as a way of indicating this is actually the kind of view that I want to defend, that we have an ability to retain certain kinds of experiences, the explanation of which is only possible is best explained by a commitment to the idea that we have memory traces in a certain way. But philosophers have defended a range of these kinds of views. So I'll just, the second option, the preventing causal gaps, right? If you think about that basic characterization of the experience, right? You have an experience and later there is some, you heard me say the word marshmallow, later you're talking to someone about how strange it is that I said that. There has to be some way in which that later experience is due to or because of that prior experience. And if that's the case, you might think they're causally related. You might similarly have a view, or you might further have a view of causation, which says the causation can't have gaps, and so something has to be supporting that kind of a gap. That tells you something about the kind of commitment to a memory trace that you'd get out of that sort of a commitment. I'm not defending that view, I'm just articulating it as the kind of one could have. So we can give lots of reasons why we think there's a memory trace, and they shape how we think and what we think the memory trace would have to be like in order to play that role. Neuroscience, similarly, as I sort of pre-said already, but is thinking about this in terms of something like a functional characterization of what kinds of changes we're looking for. We're sort of looking for what could possibly support those kinds of experience-dependent changes that persist long enough to support later activation of remembering, right? We're looking for things of that sort. Again, I'm not going to tell the story of neuroscience, and that's not my role in this particular case. I can talk more about how I think these commitments come up in particular discoveries, right? But the neuroscience, the neurobiology of memory is a long history of discovering that certain neural structures are particularly important, and these are often structures in the hippocampus, and then discovering in particular that it's the relationship between particular neurons and the kinds of increased dependencies between them that that can support the retention of new information. So again, that's a very high level, broad brush description. You're welcome to push me on it if you can remember your question all the way through both of the talks, right? But this is speaking again at very broad levels of description. The prevailing view is that the formation of the engram involves strengthening these synaptic connections between populations of neurons that are active during encoding, where encoding here is just the initial experience, right? The sort of acquisition of information during an event. Right, so we have something of a general conception of what the implementation is supposed to be like. So I think we have on the two ends a set of arguments for sort of reasons and justifications for the existence of a memory trace, and a set of accounts of what the underlying mechanisms might be like. And what we really need is something in the middle that gives us a characterization of the memory trace itself, right? What the thing has to be like in order to play that role, and more fully what the role is, such that these mechanisms are implementing or realizing that particular role, right? That's what we're after. So asking this sort of question, like what does a memory trace have to be like in order to support this experience-dependent change over time? And I'm giving you here a view that I am in the process of developing. This is something I was just starting to work on more in earnest in late February, early March of last year, and have not thought about a great deal between now and then. But intend to. So apologies for the ways in which my thoughts on this are a little stale, but this is the kind of idea of a memory trace that I'm wanting to start defending. So I think it's important that the memory trace, that the change that we have in mind as a thing that exists between the initial experience and the subsequent abilities or performances that we see or can see, is the kind of change that we have in mind has two features, that there really are two important aspects of a memory trace. And that is that there is some sort of physical change to the system, right? We're expecting that commitment, and we usually think of this as being a neural change, although we can think about what the arguments for that are. And it's a change that has to be both distinctive and persistent. I'll say a little bit more about that in a second. And the change also must be, the word I'm using here and kind of wincing as I say it, is cognitive. And I think that this has a lot of connotations. I don't mean all of them. I will probably switch terms at some point. But what I mean is that it needs the state, the change that happens has to be the kind of one that can be content-bearing or content-supporting or can support a mental representation. So it's supposed to be in some way carrying information about the previous experience such that one can think about it. Again, I'm trying to give, this will turn into, as I hope you'll see, this is meant to be a kind of minimal conception. So we might disagree, we might have different accounts of what the cognitive is, or which creatures count as cognitive, or which activities are rightly seen as supporting. But I think in order to make the commitment that what you have is a memory trace, it has to be this kind of distinctive, persistent physical change that can be content-bearing or content-supporting, such that it can encode and be involved in the retrieval of the information. So those are the two features of the memory trace. So on the point about the physical change, right, it has to be distinctive. It has to be able to reflect the particular experience that one is having. So maybe many of you are like me and thinking about the movie Groundhog Day a lot these days, if you ever saw this movie recently or a while back, right? This is where a person is just reliving the same day of their life over and over and over, right? And that can be what our lives feel like now when we're no longer going to the office and going places that we might have gone, traveling to see one another, right? And it's true, our minds can, form general patterns. We abstract general schemas and, abstract, universals from the kinds of experiences that we have. But it's also the case that we remember particulars, at least in some instances, right? So I might, back in the days when I went to work, I might take the same path to work every day, but I'm capable of remembering a particular experience of walking along that path, right? Getting a particular phone call, having a particular set of thoughts, whatever that sort of thing might be. And we want the memory trace to be able to explain those particulars. There has to be a way in which it has a distinctive impact in the system. This doesn't have to be localized or discrete in any particularly strong way, but it does have to be, so it could be distributed, but it needs to be a distinctive way of being distributed. It also has to be persistent, right? There has to be a way in which whatever is distinctive about the impact of that experience persists, that it endures from that initial experience up until, for as long as the act of remembering is in some sense possible, right? Again, just some general features that we can flesh out further. In terms of the challenge of thinking about what the mental change has to be, sometimes I think this is easiest to think about using the counterexample of the kind of thing that wouldn't count as the right sort of distinct and persistent change, which is an example I believe comes from the work of Yadi and Dudai, but I actually went looking back at a book to try to find the example, and I can't find it, but I think that it came from him. When you study memory, you often are not very good at remembering things, it turns out. But he has this really nice example where he says, imagine that you're walking across the room and you stub your toe, right? And you leave a really kind of nasty gash on your toe that leaves a sort of scar of sorts. And later on, that place on your toe starts throbbing, right? And as a result of that, you come to think about the past experience. So what we have is a distinctive and persistent change to your foot. When it is activated, you then think again about the stubbing of your toe. But I think that we want to resist, or in most cases, most of us, our idea about what it means to sort of carry information about the past experience, we're going to resist the idea that your toe is actually carrying that information, that it's actually carried in that injury itself. Now, there might be things that it's associated with. We can talk about the ways in which that's complicated, but if you have the idea that this doesn't count in the right sort of way, it's because it's not carrying the right sort of information. It's related to and reactivating what might be carrying the information, but it itself is not bearing any content. It's not playing a representational role. Now, of course, there can be arguments about what exactly is going to meet your threshold of cognitive, what is going to count as being representational. Philosophers who study the mind and neuroscience have different tolerances for where to put those boundaries, both between the brain and the world and in terms of levels of neural processing, right? So some people might might have broader accounts of memory that are going to have a broader conception of cognitive that might let more things in to be possible memory traces. Right? The immune system is capable of keeping track of certain, in some ways, showing some sort of persistent influence of the encounters with past viruses and bacteria, right? Depending on how you want to think about the ways in which the immune system does that and your account of the cognitive, that sort of thing might count. But again, that's going to depend on whatever account of cognitive you plug into this. I'm just saying that the memory trace is going to fall on the cognitive side of that boundary. Okay, so the core conception, and this is me trying to write it out in sentence form as the way philosophers would do, right? It's going to be a discrete and persistent structural feature of the system, which occurs as a result of some sort of experience that is cognitive in the sense of being content-bearing or supporting, and whose content in some way reflects the features of the experience. There's a whole lot of wiggle room and imprecision there. I recognize that and hope to get pushed around on that a bit. But it is also intentionally a minimal conception. So I mean for it to be the case that one could have different ideas about what counts as content or as cognitive or what's required for being representational, but we would both be committed to the idea that there's a trace across those differences. Or we might have different views about what the underlying neural structures have to be like, or which ones count, or which ones are going to be indications of persistent traces or not. But those will all be variations within accounts of memory traces, not accounts of has a trace or doesn't have a trace. So in part, what I'm trying to do is give some kind of way of articulating a core minimal conception of what a trace is, such that we can tell whether any particular view of memory and what is required to support it counts as a trace theory or not a trace theory. So that's some of those basics. Now I want to think a little bit about challenges to some of the challenges that exist, some of the reasons why people think that there can't be memory traces. And I'm not very far from done, but make faces if I'm going too far. So two of the worries have to do with how we think about the nature of neural dynamics and their compatibility with memory traces and the prevalence of memory errors. Again, I'm just going to introduce both of these very briefly. So neural dynamics, at one point this was set up to play. I don't know, it's just flashing neurons, something very fancy, but I managed to put a video in, so I was going to play it. We could wonder whether once we think about how dynamic our neural system is, how much it's changing over time and in any particular moment, we might wonder whether any neural mechanisms are stable enough to support what's required for the persistence of traces. I think this touches on what Maria will be talking about later, perhaps in some ways. But there are sort of more broad worries that we can have, right? And Alcino Silva has a nice quotation where he's worrying about whether or not what we know about the basic molecular processes that support the systems of memory, whether those things are stable enough to ever give us anything that looks like an engram or a memory trace. And I'm just putting him up here as one example of someone who's put the point very nicely, right? You can think all of these activities are very, right, they're dynamic, they're probabilistic, they're moving around, and those kind of things just don't have the stability to them that would be required for something to be a sort of persistent and enduring change to the system, right? We don't have anything that is the neural equivalent of a long-lasting impression in wax. Right? So just mentioning both of the challenges here before saying anything about them. The second challenge, again, there's a whole lot of research here. I'm just talking very quickly. Right? We know from the last several decades of mostly cognitive psychology and cognitive neuroscience as well, the memory errors are persistent and pervasive. Right? We're all aware that we make memory errors, but cognitive psychology has done a very good job of showing us that we make far more than any of us would have thought, and that it's easy to put us in situations where we'll think we're remembering, but we're actually not, or where we've swapped out significant important details and we can't tell the difference. And the amalgamation of all of that evidence has prompted many philosophers and neuroscientists to really think hard about what the function of memory is, right? So it looks like if we thought that, well, memory is about storing these experience-dependent changes and putting them to use, if it turns out we're actually not so great at putting them to use, if we're actually mixing them up, and our system is highly malleable and fluid in these ways, then perhaps we should rethink this idea that there were traces supporting that system, right? So, and again, I'm just flashing up some very quick results because we can talk to have the slides in case we want to talk about them later. Things like the DRM paradigm, where people remember hearing related words that they were reading them or being exposed to them when they actually weren't, or cases like Loftus's misinformation paradigm, right, where people will change their evaluation of what happened during an event based on the kind of question that they're asked, right? So in the cases of a car accident, if I ask you how fast was the blue car going when it hit the red car or bumped or collided or smashed, as a function of which of those questions I ask you, you'll change your estimate of the speed of the car, right? Showing, again, that our memory for these kinds of events, even when the interval between seeing the event and being asked is very, very small, and you're in what you think are high-stakes situations, you did get fluctuations as a function of what you're asked. Right? So one of the things I think is important to note about both of these challenges is that both of these challenges are about changes to the memory over time. Right? They're about changes to the structure in terms of the neural dynamics, changes to that physical, persistent and enduring change, and changes to the content of the memory as it can move over time. So are these changes, are these things actually compatible with the core conception? And I think, and my aim is just to show that there are ways in which, yes, these things are compatible. It's not to say there aren't residual challenges, but they can be put together. So in the claims about neural dynamics, this is drawing from a paper, maybe Marina, I didn't send around the right version of it until more recently, but it's coming out soon in Philosophy of Science. In this paper, I've argued that the claims about neural dynamics are claims saying that, look, it's of course, so we can think of the commitment and the thing that we're worried about as coming in two forms, as either being a question about whether the persistent structure is going to require a lot of dynamic activity in terms of, you know, upkeep and metabolic regulation and other kinds of processes. And we can think about it as the actual structural basis that is undergoing those things changing over time. So kind of dynamical activity of general upkeep and more serious structural changes that involve switching which neurons are supporting the engram, maybe even which parts of the neural system or which neural structures more broadly are supporting it. Right? Those are the two central claims that we can think of as claims from neural dynamics. And I think both of these are actually compatible with the core conception. So again, you could have a way of fleshing out that core conception. You could have certain particular commitments that you make in a trace theory that could make your theory incompatible. But the central idea of a memory trace is not incompatible with those sorts of claims. So to say that the structure is persistent is not to say that it is static. There's no claim that the engram or the memory trace has to be the same neurons in the same way over time in order to be persistent and enduring. You do need an account of what sorts of changes are allowable and what sorts of ones are going to be the right ones, but it's possible for there to be changes that allow for persistence and endurance, and for that what provides that structural underlying basis to change over time. Many views of things like systems consolidation have accepted that for a long time. They thought memories could move from one part of the brain to the other. And if that basic idea is even conceivable, then it shows that there is a sort of idea that it could move from being one persistent structure to another persistent structure. If we think about the case of memory errors as just drawing on arguments I've made elsewhere, many of the kinds of memory errors that we have, the sort of changes that we see, are not changes that involve the absence of memory traces, but rather the sort of distortion or manipulation of the memory trace, right? So in cases of the DRM paradigm, people are claiming to remember words as being on the list when they're related to the other items on the list, not when they're unrelated, right? That's the thing that's so tricky to explain. Like, how do they remember that this word is related to all the other words and yet not remember which words were actually on the list, right? It seems to fall in this kind of strange category. And similarly, in the Loftus case, right, it's not as if they're forgetting or just drawing from general experiences about what happened when cars collide with one another to answer the question. What's happening is they have a memory of the event, and the details of how that's remembered are being influenced by what kinds of questions they're asked or the context in which they're asked them. So we see influences on the content that come from other places. So saying that the trace itself is content-bearing or content-supporting isn't challenged by that idea. There could be particular views of content one might endorse that could get get you into trouble. But if you think that the memory trace has content to it, that doesn't mean that its content can't be influenced or manipulated in the act of remembering in ways that could be influenced by this kind of information. And similarly, just putting up quickly, I won't say anything about it, but we have examples using optogenetics from cases involving mice, right, where we see that we can implement something that looks like an animal model of false memory, where what's happening in these cases is that we have a trace or an engram, and we're distorting it in particular ways to get the false memory behaviors, supporting the idea that it's a distorted trace, not the absence of a trace, that causes many of these errors. All right, so again, the minimal conception I'm laying out has these sorts of features. So the memory trace, as I've been thinking about it, is an experience-dependent change to the system that has both physical and cognitive features. Then each of those features can itself change, and it's possible that they could change at different times and in different ways, right? The ways in which the physical underlying system of the trace changes over time could be quite different than the ways in which its content can be changed or manipulated over time. And how those things relate to one another at any particular moment and over time are things that we actually need to think more seriously about as both philosophers and neuroscientists when we're talking about how to characterize and identify and look for these states. So I tried to lay out, again, a sort of minimal or core conception of what the trace is, that it's, again, a minimal but substantive conception that has some roots in philosophy and neuroscience. It can support a range of different particular views, and it can withstand some of these sorts of challenges. And that is it. Thanks.
Thank you very much, Sarah. So, María Eugenia, you can start sharing your screen. She's going to talk about reconsolidation, and the name of her talk is Following the Footprints of the Reconsolidation Process, Its Role in Memory Malleability. So, María Eugenia.
Thank you. I'm coming. It's like very slow. Well, good afternoon. It is a pleasure for me to be part of this series of meetings. I would like to thank Cecilia for the invitation. It is a great opportunity to share what we did to follow the footprints of the reconsolidation process. Basically, I want to discuss its role on memory malleability. After a brief theoretical framework, I would like to go over some of our findings, first with crabs and then with humans. Second, I will present data that is under review of the impact of impairing the reconsolidation process of unaversive memory in humans. The brain is constantly encoding the features of the environment on internal representations. Plasticity and learning are key factors that operate updating these representations, which in turn guide animals' behavior. For example, visiting the floral patch at the correct time to find the maximum nectar peak, or being familiar with the environment to find shelter and avoid the attack of a predator, or being able to connect the last dinner with the present stomach ache. This ability allows both human beings and animals to better prepare for and adapt to present and future events. These examples seem simple associations, but give us the idea that in these terms, these internal representations or memories are flexible, malleable, and in a permanent state of construction and reconstruction. Considering the different approaches to the study of memory, we can say that there are two research traditions on dynamic memory processes: cognitive psychology and neurobiology. In cognitive psychology, the malleable nature of long-term memory has been extensively documented. For example, memory distortion represents a memory transformation implying the decay of perceptual details but the storing of the core. Then, during later recall, this conceptual skeleton is used to reveal a detailed event memory using factual knowledge to fill in the gaps and generate vividness. So, this reconstruction is mainly imagined rather than experienced. For example, flashbulb memories describe exceptionally accurate memories for public events, such as the Amia bombing in 1994, or Maradona's goal of the century in 1986, or the 9/11, or the game between Brazil and Germany in the World Cup of 2014. These memories contain not only the specific event, but also the knowledge about where this event was experienced. For example, who was there, how the weather was. So they are strong memories full of details. However, it has been demonstrated that successive retrievals induce changes of such details. These results suggest that despite the strength of these memories, it's possible to change their content. In spite of that, previous research on memory consolidation proposed that after being consolidated, memories were immutable. This concept dominated the field for more than 100 years. However, the appearance of the reconsolidation process has transformed this vision. In our field, we define steps to describe the different memory phases, and this is an example of that. After acquisition, a short-term memory requires a consolidation process which turns this labeled trace into a stable and long-lasting one. After being consolidated, memories can be modified through further experience. Inactive memories could be reactivated by cues, reminders already existent at the time of acquisition. This results in memory labelization, followed by a process of restabilization known as reconsolidation. The reconsolidation process could be the tool to update memory content. But to show that the reconsolidation process is at play, experimental designs use different amnesic agents to impair memory restabilization. As a consequence, the reconsolidation process is revealed by its absence. What I want to point out is that both research traditions, cognitive psychology and neurobiology, have not paid much attention to each other's advances on dynamic memory processes. So it could be very useful to apply concepts developed in neurobiology to phenomena described in cognitive psychology. And doing that, it could be possible to link both research traditions. Now, focusing on the reconsolidation process, a doubt immediately arises. Is the reconsolidation process triggered every time a memory is retrieved? Is it dangerous then to put a consolidated memory at risk in each retrieval? Luckily, we have shown that memory retrieval is a necessary condition, but it is not enough to reconsolidate it. The interaction between the reactivation session and the features of the target memory determines whether memory retrieval could induce memory expression, reconsolidation, or a new learning. Subsequent research has defined the boundary conditions that constrains the occurrence of the process. For example, the age of the memory. Newly consolidated memories pass through the process, but older memories do not. Intensity of training. Strong training requires a more intense reminder to reactivate the memory. To introduce two other boundary conditions, first I must introduce our invertebrate model, the crab Neoelice granulata. These animals live along the Atlantic coast from the south of Brazil to the south of Argentina. We recollect them from the rias of San Clemente del Tuyú. Their natural predators are seabirds, especially seagulls. So objects that fly over them elicits an escape response. We recreate this in the lab using this experimental device. We put the animal in this container and we move this screen. The movements of the screen elicits the escape response. The container and the environment around have specific contextual cues, and it's going to be our CS in this conditioning, and the screen is our US. So using repeated presentations of this US generate a long-term memory. The animal learned to associate the contextual cues with the US. With this contextual conditioning, we demonstrated that a brief re-exposure to the CS triggers the reconsolidation process. Without going into great detail, we demonstrated that prolonged exposure to the CS generates an extinction memory. Therefore, this parameter, the CS duration, acts as a switch leading memory to either process. And the last boundary condition that I want to mention is the mismatch. And as in other protocols, we prove that the incongruence between what the crab learns and what happened during retrieval involves the reconsolidation process. Here, a brief re-exposure to the CS labelizes the memory, but that doesn't happen with the inclusion of the US. The mismatch is a type of prediction error. It represents how surprising or certain was the outcome of the prediction made by the animal. From our point of view, the prediction error is in the core of most of the reminders. I want to highlight that different reports propose that the reconsolidation process could be used in new therapies targeting dysfunctional memories. For example, as a new therapy for psychiatric disorders as PTSD, or as the mechanism associated with false memories, or as a new tool in treatments for disorders based on maladaptive appetitive memories, such as drug addiction. However, around 2005, despite the interest, there are few reports using humans as experimental subjects, in contrast to the ones that use other animal models. So knowing that in that context, and knowing that memory processes were conserved throughout evolution, we decided to leap from crabs to humans to study the reconsolidation process of a human declarative memory. The paradigm consisted of matching pairs of cue and response syllables displayed in a specific combination of light, image, and music. We demonstrated that the reconsolidation process is only triggered by the cue reminder, which includes the mismatch. Here, the mismatch occurs when the participants could not complete with the response syllable. The next step was to study the biological role of the process. Two non-mutually exclusive functions have been proposed. One states that the destabilization of the original memory after the reminder allows the integration of new information into the background of the original memory. And the other suggests that the labelization reconsolidation process strengthens the original memory. Both functions have been demonstrated in different reports, and we also show them using our syllable paradigm. But how have we demonstrated the strengthening function? During the reactivation session, we repeated no more than the presentation of cue reminders. With this manipulation, we demonstrate that the strengthening by reconsolidation increased memory precision and memory persistence. Then we investigated the neural correlates for strengthened memory by reconsolidation using fMRI. In a previous report, Cecilia developed a new paradigm to be used in the scanner. The paradigm included pairs of picture word items. The training session had 2 trials. During the first training trial, the picture appeared, the word, a black screen, another picture, another word, and so on, until complete the presentation of the 36 items. In the second training trial, the picture appeared, the first syllable of the word, and then options to complete it. They complete, another black screen, another picture, first syllable, options, complete, and so on. During the reactivation session, we divided the items in 3 different conditions, 3 different reminders. The word reminder, which includes the picture and the complete word. The cue reminder is formed by the picture and the first syllable of the word, and the context reminder, which includes the picture only. Each reminder is followed by an interruption sign, black screen, continuous sign. We evaluated memory retention by showing the picture, and the participants had to say the word out loud. As you can see, the word reminder is similar to the first training trial. So this reminder is a retraining. And the cue reminder includes the mismatch because the participants could not complete the word. So Cecilia performed an experiment to analyze the effectiveness of these reminders on triggering the reconsolidation process. In this behavioral experiment, we included 3 groups: the reactivation group, the reactivation interference group, and the no reactivation group. All the participants learned the picture word associations during day 1. On day 3, the reactivation group received the presentation of the reminders. The reactivation interference group, after receiving the presentation of the reminders, they performed a second learning task with different pairs of picture word items. This was our amnesic agent. And the no reactivation group did not receive any treatment on day 3. Then we evaluated the memory on day 5. And for the no reactivation group, we divided the items randomly in the 3 different conditions or 3 different reminders to compare this group with the other 2 groups. And these are the results. Here we have the % of correct responses and the different reminders for different groups. And as you can see, for the cue reminder items, we obtain a significant differences between the reactivation and reactivation interference group. The reactivation interference group showed a lower % of correct responses than the reactivation group. This difference reflects the amnesic effect. So we conclude that the cue reminder was effective in triggering the reconsolidation process. The mismatch occurred when they could not complete the word. Now, I want that we observe what happened with the reactivation group under the word reminder and cue reminder items conditions. And as you can see, the cue reminder and word reminder conditions of the reactivation group show a higher % of correct responses than the no reactivation group. So this implied that both manipulations, reconsolidation and retraining, strengthen the retention of the original memory. Now we can compare the differences between the neural markers imprinted by reconsolidation with the cue reminder and retraining with the word reminder. So in this study, Luz used the same paradigm, but during the reactivation session, we only divided the items in 3 different conditions or manipulations: the word reminder, the cue reminder, and 12 items were not presented during this session. So we have retrained, reconsolidated, or no treated items. This study had 2 experiments. In one of them, the testing session was in the scanner. So using fMRI, Luz analyzed the functional connectivity of the whole brain during retrieval. Due to lack of time, I will only mention the main conclusions of this study. Words strengthened by reconsolidation are more persistent, and reconsolidated memories involve a larger and more efficient local network at exchanging information compared with memories that were retrained or untreated. As I mentioned before, the reconsolidation process is proposed as a new tool to be used in new therapies targeting dysfunctional memories. In the last year, different reports have tried to demonstrate that, in some cases with promising results. In particular, in these reports, they found behavioral changes after the treatment. Now, coming back to the first slide, we propose that the reconsolidation process is the mechanism in charge of the reconstruction of internal representations. This reconstruction is supported by the updating function of the process. In this cartoon, we propose a model. The animals make predictions based on current cues. If the prediction matches with the present event, the memory is retrieved only. However, if a mismatch is detected, the prediction error triggers the reconsolidation process, giving the opportunity to update memory content. But sometimes the prediction error is detected, but the reconsolidation process may not update memory content. For example, beliefs and predictions of a patient phobic to dogs should be expected to change after thousands of unharmed encounters. However, none of this occurs. On the contrary, it seems that these memories are maintained or strengthened. This is an example of anxiety disorders. Anxiety disorders are the most prevalent mental illnesses, including specific phobias, social phobias, generalized anxiety disorders, and PTSD. Uncertainty is the unifying factor across them, and it is experienced as a threat. Negative events result more aversive, and their consequences are overestimated. In laboratories, the neurobiological basis of anxiety disorders are studied using threat conditioning. In a new research line, our working hypothesis is that changes in anticipation or processing of aversive situations may play a role in the maintenance of anxiety disorders. This role involves a reconsolidation process with a specific bias. All in all, first, Soledad demonstrate how a threat conditioning could affect cognitive systems. This threat conditioning paradigm is able to model some of the threat processing bias commonly described in anxiety disorders. Then we try to answer the following questions. What would happen if we impair the threat conditioning memory reconsolidation? And then, if this memory weakened, would it affect cognitive biases? Here, we chose a working memory task as interference. It was our amnesic agent. The experiment included 3 groups: the reactivation high-demanding working memory group, the no reactivation high-demanding working memory group, and the reactivation low-demanding working memory group. All the participants acquired the threat conditioning on day 1. On day 2, after the reminder, one group performed the high-demanding working memory task, while another the low-demanding working memory task. The last group performed only the high-demanding working memory task. The protocol also included tasks targeting cognitive biases, such as stimuli representation and valuation. The paradigm included 3 phases: 2 angry ones, 1 neutral one. Each phase appeared 8 times. One of the angry phases was followed by a tone in the 75% of the presentations. This was our CS+. The other angry phase without reinforcement is the CS- and the neutral phase. During the reactivation session, we presented the CS+ without the tone and interruption sign. This is our reminder. And to evaluate memory retention, we presented the CSs. Each phase appeared 12 times. To evaluate the implicit memory retention, we measured the skin conduct and response. We consider that we have memory retention when we found a differential increase in the skin conduct and response for the CS+ in comparison to the other CSs. The skin conduct and response reflects the activation of the sympathetic nervous system. So the high-demanding working memory task that we used was the PACE auditory serial addition test. It is a popular measure of working memory and executive functioning in neuropsychological assessment. Participants had to listen to a pre-recorded series of numbers, and they were asked to add the last 2 numbers. For example, if the digits were 3, 2, 9, 8, the response should be first 5 and then 11. For the low-demanding working memory task, we used the same pre-recorded series of numbers, but here the participants had to answer if the digits were even or odd. These are the results for the skin conductance in all the sessions and all the groups. In the first panel, we have the reactivation high-demanding working memory group. In the middle, the no reactivation high-demanding working memory group. And in the bottom, the reactivation low-demanding working memory group. On the left, the training session, the acquisition, the 8 trials for each CS. In the middle, the response to the reminder in these 2 groups that received the presentation of the reminder. And on the right, the testing session. For each CS, we have 12 trials. In green, the CS+, in red, the CS-, and in blue, the neutral phase. As you can see, we obtained a successful conditioning in all the groups. We found an increase in the skin conduct and response, a differential increase for the CS+ in comparison to the other 2 stimuli in all the groups. We also found memory retention for the presentation of the reminder in these groups. But during the testing session, the reactivation high-demanding working memory group showed a similar level of response to all the CSs. This lack of difference reflects the amnesic effect. On the contrary, the other two groups showed retention in the first trials, showing that the memory is not affected by the treatment. And then we have the extinction because we repeated the presentation of the CS plus without reinforcement. We conclude that the high-demanding working memory task was effective to interfere with implicit memory reconsolidation. That the high-demanding working memory task, but without reactivation, had no effect on threat conditioning memory retention. And the low-demanding working memory task was unable to impair threat conditioning memory restabilization. Now, as an example, I'm going to show one of the tasks targeting cognitive bias. And to evaluate the exacerbate negative representation, we use the stimuli representation task. The participants perform this task before conditioning and during the testing session. In the stimuli representation task, participants had to rate the aversiveness of 12 different phases, including the ones that we use in the conditioning. They use this scale from 0 to 8. We estimated the stimuli representation as the mean difference score for CS plus and CS minus between post and pre-conditioning. And these are the results. As shown, the reactivation high-demanding working memory group rated the CS plus and CS minus in a similar way. On the contrary, the other two groups rated as more aversive the CS plus than the CS minus. The main conclusion of this study was that disrupting reconsolidation of threat conditioning memory with a high-demanding working memory task weakens not only the implicit memory retention, but also the representation and valuation toward threat. To conclude, the main proposal is that the reconsolidation process could be the mechanism in charge of memory updating. In each footprint that we found, we show that the detection of the mismatch is critical to labelize the memory. And in the last footprint leaves new questions. We obtained positive results with healthy subjects, but could we obtain similar results in subjects with a different anxiety profile? We are working on that after the pandemic, and this is my group, our grants and collaborations, and thank you for following our footprints.
Well, Sarah, thank you very much, María Eugenia and Sarah. So I don't know if you want to start, if you have questions to ask or some comments to do between you two, and then we are going to open the discussion to the public. So you can raise, you know how to use a Zoom, you have to raise your hand. I think you have the hand in the, you just go to participants and there you can raise your hand. So Sarah, María Eugenia, I don't know if you want to discuss a little or talk a little between you two.
I want to, Sarah, I want to say that I think that from my point of view as neuroscientist, I'm totally agree with your proposal. It's like I don't feel like a classical say, no, this is the trace, is immutable. No, I think that working on reconsolidation put my vision so near your vision. It's like we are thinking very similar. I feel that, I don't know. Yes. Because when you started and you say, well, in philosophy, the trace is required for something. And I think that if we use the ecological vision of why we need memories or why we have to adapt our memories, we're thinking the same thing or not. Do you think that we are thinking?
I do. It sounds very compatible to me. So I think people who think about reconsolidation and the longer, who are more spending a lot of your time thinking about how to track the memory over time, are already at least implicitly putting to work ideas about what you might be looking for in terms of the state over time. So yeah, I thought that was really nice. That's good for me. If we agree, that would be helpful, actually. I had a couple questions, or more, I guess it's a comment really for you, that I was thinking of. So I really like the attempts to connect the cognitive psychology and the neurobiology. So I've found that very frustrating when reading about these literatures just often don't have much to do with one another. And so finding those connections, I think, is really helpful. And I thought that some of your work on the mismatch sort of triggering the strengthening of the memory, that reminded me, again, at a very general level, of the work on, and I can't remember the name of the effect, maybe someone else here will remember it, but the thing that Roddy Rodiger and a bunch of other cognitive psychologists have worked with on testing effects, and the sort of in class. So if you want someone to remember information, if you just hit them with the information over and over, they don't actually retain it as well as you do if you quiz them or give them tests, even if they get it wrong. In fact, sometimes even better when they do get it wrong. And that's, like, you think about why that effect might be. It looks like that might.
Yeah, it's something like we have to discuss that point in our discussions in the papers, because when you publish this about strengthening and the testing effect, but if you read the reports of Redinger, they don't talk about the mechanism that underlying the testing effect. So it's that thing that I say that it could be useful to apply one concept to one phenomena. It's like, I think that the reconsolidation process could be the mechanism underlying the testing effect. But we are working in our way, and we are not looking what happened in the other. And we have to learn to look and going back, not to work, because they are a different discipline and it could be very complicated. But you have to think, you have to have an open mind, trying to say, okay, this is a phenomena, could be this the mechanism or not, and we cannot say that it's not a testing effect, but what we're saying is that the reconsolidation process is that open that trace and strength by changes in the synaptic connections or whatever there in the trace. But is this a thing to learn to see what the other topic is doing and combining is like that. But we have to discuss every time the testing effect, and it's also very helpful for the educational state. The thing of practicing instead of reading is very nice and important to apply in schools. It's like it's part of the trick, generating this mismatch, because this surprise or no can complete this what open your trace is like.
Yeah. So one other question I have, which this might be a little unfair in some ways, but I was wondering about this. So all of the paradigms that you're using with the crabs and with the people are these conditioned stimulus things, where the way of thinking about the activity as involving prediction makes sense, because it's about these sort of pairings and expectations. And I'm wondering about how we generalize this to other forms of remembering, where we do get the malleability. And what am I predicting, and why am I updating?
When I hearing your wonderful talk, I'm thinking on that you propose to analyze more complex memories. In the lab, we use very simple associations. I say that it's like this stimulus with this other and this is linked. Now we are beginning, we don't have data, but we are beginning to work with autobiographical memories, trying to know how it works. But it's like we are, I feel when in my group we talk about footprints or steps, it's like we begin with the crabs and we go slowly, no, and we determine this and go on to another step. So now we are looking for more complex memories. But I think that from the experimental way of working, you need to simplify, have the more simple trace to manipulate. It's like, because if you have a lot of stimulus or connections, but that is also is not true, because we are not a tabula rasa. We have a lot of information, and all our traces are connected with similar traces, and all are working in a net. So we said we reactivate that, but we don't really know if we are not reactivating another thing that is connected with. It's like, and from my point of view, when we talk about the translational use of reconsolidation to attack dysfunctional memories, the more complex thing is to reactivate that memories, but because these traumatic memories are particular and special for each subject. So here we work with an association between a tone and an angry face, and we show that change your vision about what is more fearful, but it's so simple, but it's not a real traumatic situation. So sometimes I don't know if we are going to arrive, but that papers that I mentioned, they show difference. The people that are phobic to spiders change their behavior. They go near the spider. It's like, it's not magic, it's propanolol and the reactivation, but they do that. You see that they are touching the spider.
Eugenia, sorry, I want to add something. You talk about the spiders, and maybe there is a prediction. Maybe the patient there is expecting that the spider, I don't know, jumps, makes something to the patient, and the patient look the cage and say, no, nothing's happened. So maybe there is a prediction and an error in the prediction also.
Yeah.
And I just want to add something to your previous discussion before I forgot, that this problem is not, it doesn't happen only in, I don't know, psychology versus neuroscience. Also in neuroscience, for example, if you read replay papers about memory replay, and then memory liabilization, and you say, wow, but maybe they're sharing things, and they are only workshops for memory replay, another for liabilization, and you see that they do not talk together.
Yeah.
So, and in this topic, in the last years, they are trying to show memory replay during sleep, for example, and liabilization. But some years ago, it was like two completely different things. So,
but this the thing that we did not discuss, or we are engaged with some type of experimental design. I remember when we published that paper with Héctor Maldonado, Cecilia, and my mentor, about reconsolidation and extinction. The only thing that we did was to change a classic parameter, the duration of something. So doing that thing, because there at that moment, it's around 2002, there are a big discussion in the field saying the reconsolidation is like an extinction, because you show the CS and this extinguishes the memory. And you say, no, it's only one CS, it's impossible. And the only thing that we do was to change the duration, and at the same time, Yadin Dudai published something similar using different number of. So sometimes we are so concentrated in one proof design that we don't think to change it. And if we change, we can discover interesting things. It's like that thing of not be in the same way all the time. I think that is the way to work in science. I don't know.
That's the idea of these seminars, is to join philosophy. I say, what is philosophy? So, neuroscience.
Okay. Yeah.
So that's what we are trying to do. I don't know if we are going to do it.
Okay.
Yeah,
I'm totally. Okay.
So now we can open to the public, so they can, all the audience can ask questions, and both of you can answer. Sorry that I interrupted, I wanted to say that.
No,
sorry.
I'm happy with the comment.
There is already one hand, I think. Juan, can you activate or?
So, do you hear me?
Yeah.
Okay, thanks. Thank you very much for those very interesting talks. But I have a question from the philosophical side of the bridge. So, and this question is especially for Professor Sarah Robbins, because it's for a particular perspective that she defends in a paper. So, in your talk, you show that in philosophy, we want to know why memory traces are required. So one of the reasons is, for example, since Martin and Deutscher's seminal paper, is to distinguish remembering from relearning. So we want to distinguish appropriate causal chains from deviant causal chains. So, for example, Sven Bernecker proposes this contiguity view in order to distinguish them. So he says that memory traces need to be temporally contiguous, something like that. But in your 2017 paper, you show that this is too permissive. We can conceive different cases, like the diary case, in which with this view, we need to say that this is actually, when we relearn information from a diary, we can say that we are actually remembering, but something is going wrong also when we say that remembering, when we say that we are remembering when we need to reacquire information again, when we need to reperceive information. So your proposal is the cognitive contiguity view, according to which the capacity to produce the mnemonic representation stays within the cognitive system. And in this paper, you say that we need to establish a boundary in order to individuate the cognitive system, and you say that this boundary is the perceptual one. So my question is, why this view? Why we need to put the perceptual border in that point? Because I mean, do you think that this cognitive contiguity view lead us to an intracranialist view? I mean, according to the cognitive contiguity view, we can't conceive, let's say, external memory traces. I mean, external devices that we use generally in order to store information, in order to, to the economy of the cognitive system. We do that a lot of times. So I am just wondering, what do you think about these possible external memory traces?
Yeah, good. So I haven't thought about the details of that argument in a little while, so I hope that I can do it appropriate justice. But I mean, the thought was, so I didn't want to exclude the idea that there could be, on that kind of argument, that some of them could be external. So they could be external to what I think of as the standard boundaries. So they might be, the trace could be on my phone or in my shoes or whatever, some part of my environment. So it would be external relative to the traditional conception. But if my mind is extended in that way, then it's internal to my cognitive system. It would have to be, and like what I took that to mean was that it was in some way importantly inside the perception, right? It doesn't have to be reperceived in order to be part of my experience. That's part of it. So I don't, as someone who isn't, I'm not an extended mind. I mean, I don't have strong views, but I don't have an endorsement of an extended view. But I think that is one of the difficulties for those sorts of views, sort of figuring out where the perceptual boundary is relative to those contents. So that was the kind of thing that I had in mind. So wherever you think the boundary of your mental space is, if you think it is the cranium, or you think it is, 20 feet in your periphery, or items you interact with, that's fine. But whatever's within, wherever you draw that boundary, it has to stay inside that boundary to count as the right kind of trace. I mean, as a broader point, I didn't defend it at all today. So I'm still convinced via Martin and Deutscher that the remembering relearning distinction is a good one. Like that was why I wrote my dissertation and started doing this all these years ago. I just thought that was absolutely right, and no one else appreciated that. And so. So I still think that that's the case, but I don't want to rely on that as the central argument for traces anymore. I think there's a range of reasons. There's a stalemate over like whether that grips you, the remembering versus relearning. And I'm convinced by a lot of things sort of coming from a very different angle, but I'm convinced by a lot of what Edouard Machery has had to say about the sort of method of cases, this kind of way of generating these sorts of cases as driving intuitions, and why this is problematic for establishing arguments. And I think we have better ways of giving arguments for them, or at least I'm trying to come up with some, which involve the range of cases where we just do retain particular information from particular experiences, which can't be explained in any other way besides these kinds of traces, or at least it's best explained that way. So I think I still have an answer, but I am trying to back away from relying on that, if that's helpful.
There is another question, Beko.
Hi. Yes, thanks, Sarah. I also have a philosophical question. I'm worried about the scope of remembering on this model. Because if you're just looking at mental or cognitive changes based on experience, that's just learning, right? Yeah. And so and of course, what is learned is deployed and used across lots of different kinds of cognitive processes. So I'm having a hard time understanding what makes this specifically memory, right? Good. And thus these things memory traces.
Yeah, good. I feel like I planted that question. That's good. So I do want to, it's a really good question. And I do want to make that distinction. So what I actually didn't put into the core conception as I had it up there today, which is in some part because I took out the argument for why I think it's the retention of information from particular experiences that is our best justification of when we have memory traces. And so that's going to play a role in the minimal conception when I want to flesh it out. That's at least the primary notion. So I think what I want to say ultimately is pretty sympathetic to what you want to, what you're kind of leaning towards, which is that there is I think there actually is a sharper than many people have realized distinction between learning and memory. There are some ways in which those processes are very, very different, right? Learning is about sort of, generalizing over experiences and getting better over and kind of acquiring and amassing and smoothing down the edges. Whereas memory, in its most distinctive case, is the case where it's like, no, I remember this person because it's nothing like anything that happened to me, right? And so ultimately, I do think it is the part. I'm just realizing that, the way I spelled out that minimal conception, I let it be like an experience where I need to be more particular about that. And that's just guilt of not doing a good job with my slides. So thank you for reminding me to do that.
Yes, Jan.
Yeah, thanks. And sorry, I also actually have a philosophical question for Sarah, though it's probably connected to other things. So I'm interested in particular in the distinctiveness constraint you've got on that conception of the trace. When you clarified that, you talked about the way that it has to allow for sort of our remembering acts to target particular experiences from the past, not just general, right? Yeah. So, but then I guess I can see going a couple different ways with this. That leaves room for what sounds like a real minimal distinctiveness, as in whatever that change is, has to enable future remembering acts whose content is distinctive of the past or something like this.
I see.
As opposed to where the distinctiveness attaches to the trace itself, which seems to me a stronger claim, right?
Yeah.
So I guess I just want you to talk about that a little bit, where that distinctiveness is held.
Yeah. Yeah, good. That's really helpful, and it's possible I haven't separated that out as much as I should. So I mean the latter and stronger bit to be what's at work there. So I think, and I think it is I've argued previously on some of the accounts that try to explain human memory and its malleability in terms of kind of general, semantic networks of information, that those do explain why, like in the DRM effect, it explains why I remember doctor when you give me words like medicine and hospital and shot. But it doesn't explain, because those words are related, but it doesn't explain like why I activate this particular list set and why I will 3 weeks from now. That's got to be something particular and distinctive in addition to those general. So I've got to have some way of reactivating that particular list learning experience or event. In order to make that happen. There's a little bit more in that I should probably explain further. But yeah, there's a way in which you'd expect, if it were entirely sort of networks of associations, and if it were entirely learning, novel and anomalous events would wash out over time, right? Things that are not the most recent or the most frequent aren't going to stick around. But when it comes to remembering, they do, at least not always. Our memories are obviously, far from perfect, but occasionally those things, they do get through even when they violate those characteristics. And so their distinctiveness has to be accounted for in that underlying structure. That's the kind of thing that I'm trying to gesture at. And the best cases we have for there needing to be a distinctive structure are from distinct events, and we get the best evidence when what's produced is so distinctive that that's the only place it could have come from. But yeah, the claim about the architecture or the kind of underlying distinctiveness is the central thing I wanted to say. But you're right, I also did not state that as cleanly as I could have.
Yeah, cool. That's helpful. Thanks.
For the moment, there is no other question, so
I have a question for Eugenia.
Okay.
It's the first time that I see the last results you showed. Great, I really like it. Yes, amazing.
Okay.
Have you got a measure, or I don't know, a declarative measure of the phase where the participants?
The declarative components did not change. They remember exactly which is the phase associated with the tone.
It's great. And I like the part where you show the change in balance of the
it's
very interesting measure.
Because
so only the automatic part, the autonomic response.
Only the skin conductor response. But the thing that we thought that we are adding, usually we use the threat conditioning to study this type of anxiety disorders. And in humans, it's more complex than only the remember of an implicit memory. You have to see the cognitive system that this threat acquisition affects. And with this simple manipulation, we are showing that you acquire a simple association and you change, you are overestimating the aversiveness of something because you receive a tone. It's like, we try we think that we interpret the anxiety disorder through the uncertainty and anticipation model of Niski and group. And they propose that we have negative schemas, and that negative schemas are activated by different events, but the anticipate response to threat, there are cognitive and behavioral changes that manipulate how you perceive the mismatch. We think that when you have have an anxiety disorder, you confront thousands of times things that show that the dog is a safe puppy and you don't have problems, but you believe that it's very dangerous and going to bite you. So at that point, the reconsolidation process is not working. You are not updating the content, or you are not updating the information, but you are strengthening the negative schema. It's like this perception of the world guide the mismatch to ignore the new information and only strengthen your previous belief. And with this, you are maintaining this memory that is associated with your anxiety disorder. It's like to say, or the reconsolidation process is not working there to update memories, or is working in that specific bias, only strengthen that memory and ignoring the new information. But they have a relation with this perception of the things and how you use different filters and it only extract the thing that you want to extract. It's like we have to prove, we are trying to perform this experiment with participants with a different anxiety profile, but we think that because we really think that the reconsolidation process could explain many changes in memory traces. But in this case, that you don't observe a change, we think that it's at play, but in a different way.
And have you got a measure, of cortisol or something like that? Because the task is really stressful. A stressful situation.
Yeah, we are planning now with a different protocol to measure cortisol. We're planning to use, the trial social stress test, that it's a stressful situation, and we are planning to combine with a friendly one and trying to see if we can change something, but it's part of our next grant. I don't know when we can do that, because you need to stay near a person, and I don't know when it's going to happen.
Because if it is stress involved in this procedure, when you labelize the threatening situation, because we already see that stress, for example, for the social stress, enhance the consolidation, or maybe consolidation. So here it goes in the other way.
Right, but sometimes it depends on the balance of the memory. The works of Wolf and Schwabe, they show that it depends on, and I also think that it depends on how we reactivate the memory and what we are putting as interference, or it's like we have to play with the parameters and the features too.
It would be great. If you
Cecilia, sorry, I think Sarah wanted to say something. Okay. I don't know
just one thing. I give the microphone to Sarah. Maybe it would be great if you could, in the same paradigm, incorporate like a declarative part, so you can see that the stress enhances the memory, and this threatening situation that goes in the other way. So maybe you can think to mix all that in one paradigm.
Yeah. It's a good idea. Thank you.
Good. That was reminding me that I wanted to, that line of questioning was reminding me that I was curious about the, like, I sometimes worry about that fear memories are in a way, things that involve fear induction are a very specific kind of memory. They're just sort of, they're very easy to compel and get. So I was wondering whether you might expect similar reconsolidation effects if you were trying to go for other valences, or trying to have them go for happier memories. So you're trying to work with depression, or you're trying to maybe even you have someone who's in a sort of manic state and you're trying to take away that evidence in some way. Do you have thoughts about what those would look like?
In humans, there are some, in animals, you have a reconsolidation of appetitive memories. It's has been demonstrated. In animals also, and we are planning to do, but then we don't do that. If you use a contextual fear conditioning, and then you put in the same place when we reactivate the memory chocolate or something like that, the animal lose the fear. It's like you are summing a good thing in that bad place, and the animal change. So you can play with appetitive or good things, playing on that. And we are planning, when we decided to work with autobiographical memories, to classify the memories like happy or sad or neutral, and looking what happened there. But it's our next project. I don't have results, but we think that it could work in a different way. But the more typical is this fear conditioning or threat conditioning.
Yes, I think also because it's easier to test, right? So it's
it's so simple. And with this idea that is associated with the anxiety disorders. It's like it's the model that everybody uses, but only seeing what happened with the implicit memory. And doing that, we are losing a lot of pieces of this puzzle, because you are only looking the implicit memory, not the declarative memory. And for us, and to understand what happened, you need to know what happened with the declarative part of the memory.
Yes. There is a question on the chat of someone who cannot talk. I think it's a question for Sarah from Nicola Andonovsky. He asks, are traces necessary for remembering? If so, are you worried about the standard arguments to the effect that necessities don't really exist in psychology? Think MR or variation.
Good. So hi, Nicola, thanks for the question. I do think they're necessary in some sense. So I do think at some level, yes, they're necessary. So that makes me stick my neck out on some Phil-mindy claims that other people might not want to stick their necks out about. So, I mean, I think the kinds of that sort of commitment about like what remembering requires is not fully the game that psychology is in. So I get that when psychology is studying acts of remembering and the kinds of what will be, epistemically able to confirm and what kinds of cases and phenomena we'll study, those things might not entirely line up with one another. I think they're importantly overlapping. But I do think I'm okay making it making it a necessity claim, despite all of that. So I'm not super worried about multiple realizability with the conception that I have, because I intend it to be, I think that minimal conception can handle, broader issues about multiple realization aside, for the people who want there to be multiple realization, I think there's room within that, not being committed to certain types of realization in particular systems. But it does lead me to, it is going to make me say that it's going to lead to certain kinds of metaphysical commitments that are going to make some other people less happy, probably including you. So maybe it's good that you can't talk, so you can't tell me what's wrong with my being okay with that. But yeah, I do mean some form of necessary, I think.
For now, there's no other questions, so I will ask you a question to both of you. That is really to talk about memory traces and the reconciliation processes, how they affect memory traces, because for what you said in general, for what I know from the literature, so the reconciliation processes can strengthen a memory trace that is already there. On the other side, it can weaken them, and maybe it enters in competition, and it can finally suppress the old trace, right? And it will be a sort of new trace that takes the place from the old trace. And then you have this other possibility that it can update it, that can update the content of the trace. So in that case, it modifies the trace, but it will still be the same trace that is related to that event. It doesn't erase the trace. So until what extent we can say that a trace that has been modified continues to be the trace of that event that is supposed to be tied in a causal sense, right? So do we have this kind of degree of modification? There's always this problem, right, of like the ship of Theseus, the idea of if something changes everything, all the parts, if we change a car, all the parts of the car, finally that car is the same car or not, it's another car. So if you want to say something about that, about how it's possible to think that memory traces, maybe then finally they are so different from what they were before when they were first created. Finally, they are not the same. They are another one and a new one.
Yeah, I think that's a really good question. So I think that there, because I wasn't articulate talking about it too much here, but I think this is one of the issues that arises because traces have both of these features, right? So there's a way in which, to put it in very philosophy terms, if you're wondering about like the persistence condition on a memory trace, so when it's going to be the same one, it can vary along two different dimensions, and different experimental paradigms and different ways of investigating them are going to use a different, not only just differences about how much similarity or difference they want to allow, but also which one of those things they're tracking. So sometimes the work is tracking the same, you're looking at the same neural system, the same neural region, in certain, especially in animal models where you very much are able to control for, be clear that it's the same neural population that's being involved over time. So that's what you're tracking over time. In other cases, you're tracking the content. So some psychological experiments, you're asking someone, like flashbulb memory cases, you're asking about the event 3 months after it happened, 6 months after it happened, and you're assuming it's the same memory so long as the content stays the same. And it seems at least conceptually possible that like the physically persistent thing and the content persistent thing could part ways. So far, I don't have views about which one is prior, how you should set the boundaries, but I've been hoping to just draw more attention to that fact, that these things might pull apart and that there are different ways of doing it, and that we should all be more explicit about which ones we're using in different cases. And that might at least help. I think there are some instances where people are putting forward what they take to be competing theories with competing evidence, but they're actually using different conceptions of the thing that they're looking for because they've picked out the thing that they're looking for, the persistence of, is different over time. So just very quickly, and I'll stop talking on that point, I think a lot of the reconsolidation stuff really is focused on looking at the same underlying structure and then allowing that the content can change in various ways. But then people who study systems consolidation, who are really interested in lifetime memories that, how it might move over 30 years, think that the memory moves from the hippocampus to parts of the frontal cortex. And it's the same memory because it has roughly the same content, right? So the content stays the same, but the underlying structure is entirely different. And so I have trouble sometimes trying to put those two literatures. Occasionally people put them into communication with each other, and it's not clear they're talking about the same things because they have different criteria for dividing up the thing that they're talking about. That's just one of the places where I think it'd be really helpful to be like, oh, okay, yes, we're both talking about traces, but I'm working with this sort of structural notion and you're working with a content notion, and we don't actually know how those two things relate to each other. So sometimes I feel like it's kind of like being a philosopher in that case is like being a like relationship counselor, saying like, this is how you're thinking of it, and this is how you're thinking of it. And maybe they're not the same.
Okay. I'm thinking the last thing that Sarah said, it's impossible to include in the same study the different angles. You have to choose one and you go in that way, another go in another way, and then we have to sit and talk together and find a way to build the idea. But if I want to work in memory in system consolidation and reconsolidation and extinction and retrieval and forgetting, we cannot, I think that it's very difficult to design an experiment that include all in the same design and you find the answer for all together. You have to find different answers for your questions and then put all together and try the construct the matrix. And the reconsolidation process gives the possibility to change memory content and strength. Weakens the traces is part of our manipulation. We reveal that the reconsolidation process is there because we use amnesic agents. I remember one time Yadin Dudai said that you are not living in a world that they give you an antibiotic in your brain and you lose your memory. It's like, it's a manipulation that we did in the lab. So on the other hand, we demonstrate that there are a lot of boundary conditions that protect your trace to enter in the reconsolidation process. So I think it is a balance. We natural in our life, the system decides when you open your trace or you don't open your trace, and we're trying to demonstrate this with simple experiments in the lab. But I think that all the boundary conditions that we found in different studies said that it's not too easy to change the trace. And on the other hand, if we generate a new trace every time we change a little thing of something, you are accumulating a lot of traces of the same thing with little differences. It's not found so useful for your brain to apply all the molecular steps to store that information when you only have to change a little thing. So it's like, I don't know, the multiple trace theory is in the field, is Nadel and Moscovich in the 90s. And it sounds as a good theory, and now the reconsolidation open another vision. And I think that we have to combine. Is that the thing? And read the all literature, because there you can find things. For example, Chapter, you discover wonderful ideas there, and with the new techniques, you can offer new insights on that idea. I think that is the best work to combine.
Okay, thank you. So I have other questions, but I think, I don't know, maybe if someone...
I think that it's too late.
Well, yes, I know, and then I can ask those questions, not a problem. I don't see any hand, so I think there's no another question coming. No. Nobody wants to ask a question? No, I think it's over. So yes, and we spent a lot of time. So I think maybe it's, if you agree, if you have something to say, Sarah or Maria Eugenia, you can say it. You're free to say, but well, no, not. Okay.
Thank you.
It was a really nice seminar. I really
thank you very much.
No,
thank you very much.
Thank you for you.
Yeah. Thanks, everyone. Thank you.
Bye.
So see you on Friday. We have the last seminar of the year, this Friday.
It's Felipe, yeah? Yes. Yeah, that'll be great.
Yeah. But in Spanish. He's going to
in Spanish.
Well, bye-bye.
Well, thank you very much, and maybe see you on Friday, and well, if not, see you around.
Okay.
See all your faces.
Bye.
Thank you.